Hmm? Okay, now we will do the ray diagrams for a convex lens, right? There are 6 ray diagrams for a convex lens. Let's concentrate on the ray diagrams for the convex lens, right? Now, for drawing a ray diagram, first you require this principal axis. Then obviously you require a lens. Can you see I am taking the lens 3 centimeters above and below the principal axis. Now this point here is known as my optical center, right? Now from my optical center on the left hand side, I will take 3 centimeters and another 3 centimeters. And on the right side again, I will take 3 more centimeters and another 3 centimeters. So this is my F1, this is my F2, sorry, 2F1, sorry, this is my F2 and here is my second focus. Now in order to complete this lens, I can use my protractor, right? I can use my protractor or I could also use a compass, right, to draw the lens, right? So I'm using my protractor in order to do my lens, right? So for this, for all the ray diagrams, this is your basic step that everyone has to do, right? This is the basic step which has to be covered, right? Now, in my first ray diagram, my position of my object is at infinity. Now, you will recall we did the images that we are supposed to do, the rays that we are supposed to draw in order to get the image of an object, right? Now, my rays of light are coming, I'll change the color. My rays of light are coming from infinity, right? So when the rays of light come from infinity, they are generally parallel to the principal axis, right? So they are parallel to the principal axis. My rays of light coming from infinity. Now this below the line also. My rays of light coming from infinity, right? Whenever they come from infinity, all these lines are parallel to the principal axis, right? Now, because they come from infinity, they all converge at F2. So, my image here will be formed at F2. My image is always formed where the rays of light converge, right? So, these rays of light, they refract and they converge at this point. We learned that a convex lens is a converging lens. So, it converges the rays of light, correct? So, please remember, since it is convex, it is converging the rays of light. Okay, so it undergoes refraction and it converges the rays of light. It converges it at this point F2, right? Now, where is my image formed? My object is formed at infinity. So, where is my image formed? My image is formed at F2, at F2. Now, obviously, you're seeing a very huge star or a planet, and I'm getting only a point sized image. So, my size of the image is highly diminished because it's a huge object. Now, always when the rays of light actually meet, the nature of the image is real, right? And whenever it is a real image, it is real and inverted. Okay, you may not understand here, but in the next diagram I'll explain to you even better. But whenever you say real, whenever the rays of light meet, it is a real image, and real and inverted go hand in hand. It cannot be real and virtual, it cannot be real and erect, right? So it is real and inverted, virtual and erect. Is that clear? So this is my first diagram. So now the position of the object is beyond to F1. Okay, now we have to follow those 3 rays. Out of 3 rays, we need to draw 2 rays in order to get the image of the object. Now for our convenience, I mentioned you take this 3 centimeters and another 3 centimeters, on the other side also 3 and 3, 6 centimeters. Now our object you take at a distance of around 1.5 centimeter from to F1. Okay, you can take it anywhere, but for our convenience we will take it 1.5 centimeter. And don't take a huge object. Okay, just you draw it. When you draw it, you use your ruled paper. So actually one ruled paper size, right? Now what are the rays of light? There are three which you learned. Okay, so the first ray of light is the ray of light which comes parallel to the principal axis. Okay, it refracts and it bends at F2, and it bends and passes through F2. It passes through F2. And the other, it directly passes through this. What have I told you this is? This is my optical center. So it passes without bending through the optical center, right? So wherever the two rays of light meet, that's where my image is formed. Okay, now my image is formed here. Now I can easily write, where is my object? Object is beyond 2f1. My image is between f2 and 2f2. f2 and 2f2. What is the size of the image? The size of the image, it has become smaller than the object. Okay, so in your textbook it is written smaller. Okay, so you also write smaller. I prefer the word diminished for understanding. Okay, and nature of the image, I told you the rays of light are actually meeting, therefore it is a real and inverted image. It is a real and inverted image, right? So we write real and inverted. Nature of the image, I told you, real goes with inverted, virtual goes with erect. The direction is very important. Okay, now let's go to the next ray diagram. Let's go to the next ray diagram. This is the position of object when the position of the object is at 2f1. Okay, once again I have drawn the ray diagram and I have kept it the axis, and I have kept it ready for you, right? Okay, so we'll do this. Now I told you, don't take very big sized image, then it becomes a little problem, right? Let's take it at 2f1. So we will take the size of the image approximately 1 centimeter, right? Now I told you my first ray of light passes through is parallel to the principal axis, and it passes through F2. The other, it passes through the optical center, right? It passes through the optical center. Now if you do this diagram really very carefully, we get the image exactly at 2f2. We get the image exactly at 2f2 if we have drawn the diagram properly. This is the only one you actually have to remember. So what is my position of the image at 2f2, right? So one ray parallel to the principal axis passing through f2 and other directly passing through the optical center, right? Wherever they meet, that's where my image is formed. What is the nature of the image, right? The nature of the image is real and inverted, and you will note that the size of the image is the same size as the object, the same size as the object. Now sometimes the image does not come exactly at 2f2, right? If you're not very precise. So what you have to do is you first draw the image there and then you draw the rays of light backwards, right? So this is my third ray diagram. Now moving on to the fourth one. The position of the image is between f1 and 2f1. Now as I told you, f1 and 2f1, take it exactly in the middle. You can take it anywhere, students, but take it exactly in the middle to get better results, right? Exactly between f1 and 2f1. I always take it at 1.5, and I take the size of the image also as exactly 1 centimeter. I always take it like this, right? This is only for convenience, right? Not, there's no rule like this. Now one ray of light comes parallel to the principal axis, and it passes through f2. It passes through f2. The other ray of light passes through the optical center. Okay, the other ray of light, it passes through the optical center. Now my image is formed beyond 2f2. My image is formed beyond 2f2. Please draw the direction of the rays of light. Okay, position of the image is beyond 2f2. Now what is the nature of the image? The nature of the image, the rays of light are actually meeting, so it is real and inverted. Now you actually measure this. This is around 1 centimeter. See very clearly. Now this is much greater than 1 centimeter. It's around 1.3. So what type of image it is? It is larger than the object. I am using a thick sketch pen so that the clarity of the diagram is there. So that's why you can't, because it actually comes very nice and clear. Want to take a break? The object is at f1, right? Now the incident ray is parallel to the principal axis, and my refracted ray passes through the focus. I can draw another ray of light, right? But this third ray I use, my incident ray passes through the optical center, and it does not undergo any deviation. Okay, it does not bend because it passes through the optical center. Now do you notice something about these two rays of light? These two rays of light are parallel to each other. So whenever rays of light are parallel to each other, they will meet. But where will they meet? They will meet at infinity. Okay, infinity, large distance, right, away from us. And what will be the nature of the image? Obviously they will meet each other, right? So it will be a real and inverted image, and the size of the image will be highly magnified or very large. Okay, very large, because whenever they meet, a large image will be formed. Is this clear? Please remember to draw the direction of the rays of light. Now this is my last. Okay, now please understand, this is my optical center. Please see that you mark the optical center everywhere, right? Now this is between O and F1. As I said before, we'll put it right in the middle because it becomes little convenient for us, right? You can put it anywhere, and 1 centimeter, again it's for our convenience, right? Now a ray of light parallel to the principal axis, and it passes through F2, and a ray of light which passes through the optical center without any deviation. Now can you see the difference between this ray of light and this ray of light? Can you see here, these two rays of light are going parallel to each other. They are parallel to each other, but these two rays, they are diverging, right? They are moving away from each other. So in order to make these two rays of light meet, we have to produce it backwards, right? This is when the rays of light don't actually meet. So therefore we get a virtual image And in this case, can you see the image is erect? All these images up till now, that whatever we have got, they have always been inverted. Okay, ulta. So real images are always inverted, right? So this is parallel to the principal axis. Image is formed anywhere here, right? It can be formed anywhere, it does not matter where it is formed, but we have to say that the image is formed on the same side, on the same side of the lens as the object. Okay. Now, what type of image is this? Very careful. What is the nature of the image? The nature of the image is, it's a virtual image because the rays of light do not meet, and as I told you, virtual and obviously you can understand it is an erect image, right? So virtual images are always erect, and the size of the image is larger than that of the object. Okay, it is larger than the object. Okay, so this is for my ray diagrams of convex lens, right? I will continue with concave lens in my next video.